Okay, welcome to the specialist forums of Chilventa. And my name is Andreas Binder. I'm product manager of the company Gohl KTK. And I will present to you the comparison of different recooling systems under the aspect of carbon footprint. So recooling is very important because you see here, for example, this is the summer of 2019 and the temperatures in Frankfurt am Main. So you can see we have an average temperature in the summer of 22.14 degrees, but we have different maximums on 3 days that are above 35 degrees Celsius, and they reach in a maximum 39.4 degrees Celsius. So if you have now designed a cooling system with a recooling unit at 35 degrees, you will have probably some problems with your refrigeration plant or with the chiller in the 3 days where it exceeds the 35 degrees Celsius ambient temperature. So what is done normally in that case? So if you ask a refrigeration contractor, they put normally some water hoses below the condenser, for example. And now we are in the area of evaporative cooling. And this system with the water hoses has many, many disadvantages. And we are supplier of evaporative cooling equipment. So I want to show you how it can be done better. So to have a good comparison between two extremes of evaporative cooling, I will talk in the following minutes about the classic open type cooling tower, which is of course a little bit a big unit for industrial cooling, for example. And on the other hand, for adiabatic solutions, which humidify the air in front of a traditional heat exchangers, which can be adapted to several capacities as well. Why do we do this? The evaporation or evaporative treatment of the air. Well, I showed you the dry temperature, like we call it, has, especially in the summer, very high peaks. If we go to the wet bulb temperature, the temperature chart is more even, and of course it's very much lower, the wet bulb temperature, than the dry temperature. So you see here we have a maximum of 39.4 in the dry temperature again, but the wet bulb temperature only has a maximum of 21.9 degrees. And evaporative cooling systems have the advantage that they are calculated based on the wet bulb temperature compared to dry cooling systems, which are calculated with the dry temperature. So let's give you an overview of the points I will discuss mainly in the next 15 minutes. So I will have a quick look on the raw materials used for the recooling system, a short view of the production, and of course the main topic will be operation of the cooling system. And afterwards we will have a short discussion about the end of life of the product. And of course we have other points which contribute to the carbon footprint of the system as well. This is energy supply, transport of the units, transport of raw materials, etc. And of course other emissions which could probably occur, and in some cases also some environmental effects. So let's go to the theory to show how adiabatic systems and open cooling towers work in the Mollier HX diagram. So here you have the division of the humidification pad and the heat exchanger in two parts. So we have two separate processes. One is the humidification of the air, and the other is the cooling of the fluid to get the heat to the ambient. So what happens in the Mollier HX diagram is we have the air inlet, we humidify via the pad, and as a, just a rare, we won't reach here the 100% humidity line. and I think it has somehow moved a little bit up because we should reach here with the pads around 90% of relative humidity. And afterwards, we have a heater process, which simply is lifting the temperatures back up to the temperature in the air outlet. The system in an open type cooling tower looks a little bit different. There we go. Yeah, this is now a little bit moved, sadly. There we go until the 100% humidity line, and then we have a process which is around the humidity line. So we can say we have there in the heat transfer area an water-air mixture which has not only heat transfer but also the exchange of the fluid and the gas. Now let's just, as an impression, compare a cooling tower in terms of energy efficiency to a dry cooler. So there's an value based on Euroland data for dry coolers. And it only compares the capacity of the cooler to the electric consumption of the fan. And you get a value which is called simply ratio value, so short for air. And it ranges for typically dry coolers up to 230, which are then classified as A+ coolers. With the adiabatic coolers, we normally reach similar values of the energy efficiency like dry coolers, because as I told you, it's the same principle. We have a traditional heat exchanger coil and we only have the evaporative pad in front of the heat exchanger, so that it's quite a similar process than a dry cooler in terms of energy efficiency. Of course, when we go further afterwards, the effects to the refrigeration plant, the energy efficiency will be better of an adiabatic cooled system than a dry cooled system. But that's not the question of the comparison in that sheet. When you use a normal, traditional open type cooling towers, we already reach the same values. These are here in A+ classified like traditional cooling tower. If we do the upgrades, which have been common in the area of dry cooling in the last years, so change for EC fans, increase area of heat exchange quite much, then we can reach with an open cooling tower an energy efficient ratio which is around 9 times higher than that of a good dry cooler. So let's see what are the capabilities of lowering the temperature of the condensing temperature with a evaporative condensing or adiabatic unit. So you can say in special cases we have, or in any case, we have the 22 degrees as design temperature, because in the summer 2019, which was really hot, we had a maximum of 21.9 Kelvin degrees Celsius in a maximum, and we designed then on 22 degrees Celsius temperature. If you use an open type cooling tower, the minimum water temperature which could come out of the cooling system would be around 26 degrees, and with an adiabatic cooling system you could say the water temperature which is coming out on the adiabatic cooling system will be around 30 degrees. So you we have a difference here which also will affect the condenser. So to have an overview about the whole year or a load profile, I had to look something where I could find a load profile, how the cooling tower or the adiabatic cooler can work. So I had a look at different directives, and then I found one which was very nice. So it is the EU Eco-Design Directive 2016 for comfort cooling water chillers, and they have a really easy to compare load profile for the chiller especially, but what applies to the chiller can also be applied quite easily to a cooling tower, because we see here the directive says if I have 100% capacity, air inlet would be 35 degrees, wet bulb temperature could be 24 degrees, and then I should have at the inlet 30 degrees, and then I made a calculation. 35 degrees is quite normal, and I did some assumptions. So I kept the mass flow through our cooling system constant, and with that I calculated the outlet temperatures. And of course I had here to look a little bit on our experiences, how big the wet bulb temperatures could possibly be, and also this load profile of working hours in the of the cooling tower or adiabatic cooler would come out of the European Eco Design Directive. So then I had to look up for the CO2 values. So I took them out of a paper published by German government, and the cost of power and water, I made some assumptions based on common values which are normal in Germany. So we see here the water values of the open and the adiabatic type compared. So of course the open type cooling tower will consume a little bit more water than the adiabatic type. But of course then this also accounts in costs. So the costs for water of the open cooling tower are similar to the consumption of the water. And you see here the assumption for the water CO2 footprint. They are also in the same dimension. If we go to the electric capacity of the adiabatic cooler and the new designed open cooling tower, we see here we have the factor 10, which we found before in the only view of the fan as well. And of course, you see here an open type cooling tower can be very, very energy efficient compared to adiabatic systems. This also leads to lower temperatures in the process of the chiller probably. So when we say, I know it's a big rule of thumb, but if you say, okay, per Kelvin, which you lower the condensation temperature of the chiller, you can gain 3% energy efficiency at the chiller. Then you could see with the adiabatic, we will have an increase about up to 10 Kelvin, and this could account probably to up to 30% after the rule of thumb, but this is really a very uncertain rule of thumb. And when we go to the open type cooling tower, we probably could lower the condensation temperature on hot days by up to 15 Kelvin. But then I wouldn't say we save such a lot potential of energy. Let's have a look at the carbon footprint of the cooling tower. So a cooling tower is a quite easy product. You only have metal sheets and some infills of on packings of plastics, and they are mounted together. So you see here our plant in Dormersheim. It's very equipped with solar panels, so our power supply is quite CO2 neutral, and we don't do much which doesn't require electric energy. So mounting, sheet bending, sheet processing, all are solely powered by our solar panels. But of course we do not know how the components we install, like heat exchangers, etc., which carbon footprint they bring until they are brought to our door. But of course we can have a view on the carbon footprint of the different materials. So also that is based on the governmental sheet I showed as a source before. But you see here, for example, the carbon footprint of galvanized steel is the half of stainless steel. But if you have then a look in the environmental declaration of some manufacturer, of course, then it may be that the carbon footprint even lowers. And this makes the calculation of the carbon footprint of a recooling system really, really difficult. More extreme, it's for aluminum sheet metal, which is mainly used in finned coils as fins. If you have new aluminum, you exceed very high carbon footprints. If you use recycled aluminum, the value decreases quite high. So there to make a comparison is quite difficult. But what we can say, the two units we are doing comparison at the moment, they weigh different weight. So an open type cooling tower, it has less mass than an adiabatic cooling towers, which consists of copper and aluminum heat exchangers. So by that multiplier, you can see probably the open type cooling tower is the more environmental friendly one. So if you have a particular barrier checked, this was just to give you an overview what are some possibilities you have with recooling systems. In a particular project, we can go more into details and pay account to local climate, the pumps for the water supply, water testing, water treatment, which is especially very important for the open type of cooling towers. To come to a conclusion, what are the main benefits of the two recooling system? Open type cooling towers, of course, what is there necessary is to take into account that we need a water treatment, and they are extremely energy efficient. If you have the adiabatic dry cooler, we say it's more a solution to cut capacity peaks of high temperatures in the summer. And the big advantage is that you have normally in Germany, you don't have to care about water treatment because you can use fresh water for the adiabatic humidification systems. So, just a short, who brought to you this presentation? Skoll KTK is a German branch of the Cofin Group, and we consist of the evaporative cooling companies DEXA, Skoll KTK, and Chassir, which are all located in Europe, so Germany, France, and Italy. And we have the most complete product portfolio in terms of evaporative cooling, from open cooling towers, closed cooling towers, to sprayed hybrid coolers, and also, of course, the adiabatic dry coolers and condensers. So with that, I want to thank you for your attention. If you have any questions, feel free to ask. I think I'm perfectly on time. In any case, if you want to have a coffee break and go more into detail, you are invited to our booth, which is in Hall 7A, booth 501. Thank you very much for your attention and have a good fair.